And the last one, last of our videos before we really get things rolling in a few weeks in August. Family fun, binomial probability. Again, I told you with describing distributions that there will be a question on the free response that has to do with describing distributions. Same thing with probability, and this is the section that last year my students did the lowest on, and also students across the country did the lowest on. So it's something that I really tried to focus on in my training this year and get good ideas. I've got a different approach for probability that I think made more sense to me. I think it will make more sense to y'all. And this is just a brief little intro to how we can make things happen. Okay? So basically you have a family, husband and wife, they love each other very much, and they decide they want to start a family. If you have any questions about how that happens, you can ask your parents. And they want to have 4 kids because they have lost their ever-loving mind. I have 2 kids, and oh man, they're crazy. But anyways, they want to have 4. And clearly you can have boys or girls. Those are the 2 options. And that is what's detailed in the chart above. You can see the different outcomes. Okay? So you can have 4 boys. You can have boy, 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 boy. You can have 3 boys, boy, 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 girl. You can have 2 boys, boy, boy, girl, girl. Girl, 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 boy. Girl, 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 girl. Okay? And there are, other ways that you can have some of the other options. Okay? So like 4 boys, that one's kind of set, right? You can't have 4 boys any other way. Okay? 3 boys, you could have another way. You could have, here's the one they have, boy, 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 girl. You could have boy, boy, girl, boy, right? There's still 3 boys. You could have boy, girl, boy, boy. Or you can have a girl first and then have 3 boys, okay? So you need to list out all of the possibilities, which we can, okay, so 2 boys, you could have 2 boys, and then 2 girls, clearly. You could have boy, girl, boy, girl. Okay, you could have, you could have a girl first, and then a boy, and then a girl, and then a boy. You could have a girl, and a girl, and a boy, and a boy. You could have a girl, and a boy, and a boy, and a girl. I think I've covered them all. Nope, there's at least one missing. Boy, girl, girl, boy. I think that's it. Maybe I missed some more. I would say, he might find another way, but y'all are not here with me. There should be 2 more, and I'm just forgetting about them. Boy, I do boy, girl, boy, girl, boy, girl, girl, boy. Yeah. I think there's 2 more though. Nope, there's not. I think I figured out what I was thinking. Okay, I think that's it. I can't think of any more. We'll go with it. If I'm missing a combination, that's not really the heart of the idea anyway, so it'll be all right. 1 boy is going to look identical to 3 boys, just with a letter swap. Girl, 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 boy. Girl, girl, boy, girl. Girl, boy, girl, girl. And boy, and then all girls. And then you have 0 boys, which is just all girls, okay? So number 1, it says, what is the total number of outcomes? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 total outcomes. How many outcomes have at least 1 girl? Okay, well, all of them but this one, right? This is the only one that doesn't have 1 girl. So 15 of them have at least 1 girl. These have 1 girl, these have 2 girls, these have 3 girls, these have all 4 girls. So at least 1, that's really important, is 15. At least 3 girls is going to be this one or this one, which is 5. At most, 2 boys. That's going to be everything but the 3 and the 4 boys. So 1, 2, 3, 4, 5. So 11. 11 of them have at most 2 boys, either 0 boys, 1 boy, or 2 boys, and the other ones have more than that. Okay. So number 2. What is the probability that a family of 4 children will have 2 girls and 2 boys? 2 girls and 2 boys. There's 1, 2, 3, 4, 5, 6 of those, and there's a total of 16. So 6 over 16, which would be 3 over 8. If you reduce it, you can just divide it into a fraction, just 0.375. Okay, let's get this straight right now. Anytime you have a question that says, what is the probability, what is a proportion, what is a whatever, probability proportions are always, always, always between 0 and 1, 0.375. Never, 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 ever, ever more than 1. Okay, never. Always 0 point something, or just 0 if something's straight up impossible, or if 1 if something is guaranteed to happen. Okay, what's the probability it's going to be hot today in Alabama? It's a 100%. It's always hot in the summer. Okay, but 0.375 is a probability or a proportion. Do not put a proportion or a probability as being 5.6125. That just doesn't make sense. That's like a 561 chance of something happening, and it's not possible. Okay. All right, number 3. The probability of having no boys in a family with 4 children. No boys is this one. It means there's a 1 in 16 chance. Okay, which you can divide that out if you'd like. 1 divided by 16. I'll do it real quick just because, why not? 1 divided by 16. 0.0625. All right, that's pretty much all you're doing, guys. Number 4, what's the probability that the oldest child is a boy? Okay. So the oldest child is a boy is going to be ones where B is the last letter. So we have 1, 2, 3, 4, 5, 6, 7, 8. 8 out of 16, which is 1/2. Guess what? Just think about it. The probability your oldest child is a boy or a girl. Okay? Well, your oldest child has to be either boy or girl. So 50-50 chance, disregarding any other type of reason why you can make a kid a boy or girl. But if there's a 50% chance of the kid being a boy or girl, it really doesn't matter that it was the oldest child. It would be the same thing for the youngest child being a boy or girl. Okay? Basically, you're asking what's the probability that a child is a boy. It doesn't matter its oldest. Same for oldest, youngest, middle kid, whatever. Okay? And so on. So you can kind of figure those out. Okay? The next page kind of has some information on Pascal's triangle, which might be kind of fun for you. Just do the best you can on those, okay? But probability is really important. It's just important right now. I just want you to understand that a probability is between 0 and 1, looking at what this is called a sample space, where it gives you all of the possible outcomes and being able to select, okay, this one, this one, this one, this one, and this one, and so on. Okay? So thanks for tuning in. Hope you enjoyed. Hope you got something out of these videos and you are ready to go in the next week and a half-ish, okay? And I'll see you guys on August 8th. Bye-bye.